Hello guys, welcome to 21 days of code series with Ozone. Today's first problem is range sum of BST. Let's jump straight onto the whiteboard to understand the problem first. Given the root node of a binary search tree, return the sum of values of all nodes with the value between L and R inclusive. The binary search tree is guaranteed to have unique values. Now, what is a binary search tree? Binary search tree is a special kind of binary tree which has all the values left to the root smaller than the root and right to the root greater than the root. That's what is BST. Now we'll dig into an example so that you get a clear understanding of what the problem is trying to ask us. Here they're telling us to find all the values of the nodes between the range L and R and return their sum. So for example, in this tree that's given to us, the nodes are 10, 5, 15, 3, 7, null and 18. So this will be the tree that will be found by these nodes, and given to us the value of L is 7 and R is 15. So between 7 and 15 there are certain nodes that lie and we need to return sum of all those nodes. So once this node is 7, and also we'll be simultaneously keeping a track of the value that is to be returned. 7 plus 10 is less than 15 and greater than 7, so we'll include 10 also. Number 15 is also in the range 7 to 15, so we'll add number 15 to the result. And no more nodes are in this range because 5 is less than 7, 3 is less than 7 and 15 is greater than 7. So for this case, we'll be returning result 32. And yeah, that's the answer for this problem. Now, how do we deduce a solution from this concept? So as you can see, we were traveling across the depth and considering each node like this. So that's more or less a pre-ordered traversal, in which you visit a node and then move to the left side and then the right side. And in this process, we'll be keeping a track of the values that lie between the given range, and we'll add all those values and return the sum that's desired to us. Now let's jump right into the code so that you get a more clear understanding of what I'm trying to explain. So here, the function signature gives us root, the left value and the right value, and as discussed, we'll be applying a DFS, that is depth first search. So we'll first define our function. This function will carry a node, the left value and the right value as parameters. Alright, and we need to keep a check whether our current node is null or not. So if current is equal to null, we'll simply return. Else, what we need to do is that if cur not val is greater than or equal to L and current dot val is less than or equal to R, we can simply add this to the sum. If current value is greater than L, then we can continue our search in the left subtree. And in the case the current dot value is lesser than R, we can keep on moving to the right subtree. And as you might have noticed, we have used a sum variable, so we need to define it globally. And we'll also initialize it to 0 at the start of our function. Then we'll be calling DFS with initial parameters root, left and right, and towards the end we'll simply return sum. Now let's try out the simple test cases first. Okay, this one worked. We'll try out another case. Okay, this also worked. Now let's try to submit the code to this problem. Okay, so it got accepted. Thank you for watching.